Hello everyone. So we're now going to continue our discussion. So I ended up with this presentation. So with this slide. So we now proceed with our next topic. So our next topic now is hydrostatic force on a curved surface. Okay. So we have the first case. Fluid is above a curved surface. So let us consider this figure. So we have here a curve area. No. So I have, let's say this is curve AB. No. So before this is a plane surface. No. So we have a plane surface. Okay. So before that is a plane surface. No. So dati ganyan siya. Diretso lang. No. So tapos ito siya yung kanyang length and width. No? Sa plane surface. So this time, curve naman. No? Curved surface. So for a curved surface, so fluid is above a curved surface. If fluid is above a curved surface, so above here we have the free liquid surface, and this is now the force, the hydrostatic force acting at this curved surface. No? So actually, three-dimensional yan. No? So three-dimensional yan. No? Okay. Okay, so sa area na yon, no? So yung sa surface na yan ay diyan nag-a-act yung ating hydrostatic force, no? Okay, so we now proceed. So this is our hydrostatic force. Okay, and it has two components, no? The horizontal component F1, okay, and also the vertical component F2, okay. So in this case, let's consider the horizontal component F1, okay, and also the vertical component F2, okay. So if the fluid is above the curved surface, this will be the direction of the hydrostatic force. And since this is the direction of the hydrostatic force, so F1 will be now directed to the right, F2 will be directed downward. No? So this is true for a curved surface of which fluid is above it. No? So we have here F2, and we have the hydrostatic force F, and we have the angle to consider between F1 and F. So let's say that is angle theta, and in this case we have a right triangle, and we can apply the Pythagorean theorem in solving for the hydrostatic force F acting on the curved surface. So that is square root of F1 squared plus F2 squared. Then we can find the angle between F and F1. Okay, the angle between F and F1 can be obtained by taking the arctangent of the ratio F2 over F1. Okay, so arctangent F2 divided by the F1. So let's now consider the vertical projection of this curve. Okay, so this is the vertical projection of the curve. Okay, and in this case, this the force F1, okay, is acting at the center of pressure of this vertical projection. No, it acts at the center of pressure, and the force F1. So it's similar to my previous discussion. We can obtain the force F1 by using the formula, the specific weight of the liquid. Okay, then we have the distance between the free liquid surface up to the centroid of this area. No, so this is the centroid of this area, and this is the from the free liquid surface down to the centroid, so that is HC. No, and this is the area of this vertical projection. No, okay, so we imagine ganito siya. No, we imagine na ganyan siya. Okay, so yung rectangle na to, siya yun, yung area na yun. Okay, so then area. So that's the computation in finding for F1, the horizontal component of the hydrostatic force. So we have here the statement: the horizontal component of the hydrostatic force, so that is F1. No, so the horizontal component of the hydrostatic force, that is F1, on a curved surface is equal to the normal force. So take note, normal force on the vertical projection. So when we talk about normal force, the area is perpendicular to the force applied, no, to that area. So F1 is perpendicular to the area. That's why F1 now is called normal force. Is equal to the normal force on the vertical projection of the surface. So this is the surface of this this material. Let's say this is a gate, no. So this is the curved surface, and we consider the vertical projection of that surface. And considering that the horizontal component F1, okay, acts at the center of pressure of that vertical projection of the surface. So the component acts through the center of pressure for the vertical projection. Okay. Now we consider the vertical component F2 of our hydrostatic force. Considering this figure, let's say up to this point, so this is the gate, this is the curve path. Okay, okay, so this is this curved surface, and above it is liquid, right? At this part we consider the liquid above it. Considering that, so this is the free liquid surface, and this is the vertical component of the hydrostatic force, which is F2, acting at this point, which is the center of gravity of the mass of volume above this curved surface. So this is the center of gravity of the mass of volume contained, no, amount of volume contained above this curved surface, no? So, in here, in short, ang center of gravity, ito yung centroid ng volume. So, kasi ano yan eh, kung extend natin yan, ito yung ano natin, okay? So, meron niyang centroid. Actually, yung actual niya dito talaga eh, no? Yung center of gravity. Sabihin niyan, centroid ng volume ng tubig ng liquid na nandito. So, in this case, dahil ang liquid na to may mass, okay, therefore, dahil may mass, tatawagin natin siyang center of gravity of the mass of volume above the curved surface. Okay? So, we consider the specific weight of the liquid, and this is now the considered liquid. Okay? So, we project it. Okay, so in that case, this is the volume formed, no? This is the volume of water. The volume of liquid, no? Above this curved surface. Okay? So, yan. So, yan ang volume ng liquid above that curved surface. Okay? So, nandito yung curved surface. Ito, nandito siya. Ayan, yung surface. So, kumbaga, binubuhat niya tong tubig na to sa itaas. Yung liquid na to sa itaas, no? Kumbaga, binubuhat niya. Okay? At meron yung timbang. Meron yung weight ng tubig. Ang weight ng liquid na yon, yun yung force na concern natin. Okay? Yung force F2 na kung saan ang center ng mass of liquid na to, okay, ang tatawagin natin yung center of gravity kasi center of mass of liquid. Okay? Center of gravity. Okay? So, in that case, ito yung ating formula for finding F2. No? Yung F2 na yan, equal yan sa weight of the liquid. No? Weight of the liquid, di ba? Ang specific weight is weight over volume. So, therefore, ang weight ay product ng specific weight and volume. So, kung mapapansin mo, meron siyang V na may paganon. Sabihin niyan, liquid volume. Volume of liquid. No? Sabihin niyan, volume of liquid. Specific siya. Okay? So, yan ang formula para sa ating F2. Okay? So, this is the volume. And this is the force, which is equal to the weight of the liquid above this curved surface, acting at the center of gravity of this volume. Okay, so for case 1, so this is true for case 1. The vertical component, which is F2, of the hydrostatic force on a curved surface is equal to the weight of the volume of liquid. No, weight of the volume of liquid above the curved surface. No, the component acts through the center of gravity of the mass of fluid contained within the volume. No, so the component, yung F2, acts through the center of gravity of the mass of fluid. Ito yung ating liquid, no, mass of liquid contained within the volume. No, so yung mass, no, that is contained yung mass of fluid that is contained within this volume. Okay? So, doon siya nag-act, no? Sa center of gravity. Okay? So, we now proceed. So, this is for case number 2. So, for case number 2, fluid is below a curved surface. So, this time, below the curved surface naman. Okay? Sabihin natin, ito yung ating surface, curved surface. At yung fluid is below this curved surface. So, ito yung fluid natin. So, this is the free liquid surface. And we consider this part, this part also. So, this is the vertical projection of this curved surface. And in this case, so itong vertical projection na yan, meron niyang area. Yung kanyang right side view. Ito yung kanyang right side view, no? Ng vertical projection. So, ito yung ating center of pressure dun sa vertical projection. Ito yung ating centroid ng area, no? Dun sa vertical projection. So, ito yung area ng ating vertical projection. And this is where F1 acts. The horizontal component of the hydrostatic force acts, no? At the center of pressure. So, ito yung ating centroid ng area and ito yung HC natin. Okay? The distance between the centroid of this plane area, no, to the free liquid surface. So, ito yung formula natin ang pagkuha ng F1, the specific weight of the liquid multiplied by HC multiplied by area. So, consider naman natin yung F2, no? The vertical component of the hydrostatic force. So, the vertical component of the hydrostatic force for case 2 is directed upward. Kasi if the fluid is below a curved surface, sabihin may force na nag-a-act pataas, no? Doon dito sa curved surface na to, may force na nag-a-act pataas. Okay? So, that is F2. So, if that is F2, so ito siya ngayon, yung F2 natin, and it acts at the center of gravity. So, nandito yung ating center of gravity. Take note, for case 2, okay, we imagine that the empty space here, no, yung empty space natin dito is filled with liquid, no, is filled with liquid which has the specific weight gamma, no. So yun ang ating computation sa computation part. So we consider the liquid. So meron tayong imaginary liquid sa loob, no, dito sa part na to. In actual, wala naman talagang liquid dyan, pero para sa computation part, we imagine na merong liquid dyan, no? So this is now our imaginary liquid, no? So kung ganon, so sa area na to, imaginary liquid yan. Kasi ito yung actual liquid, ito yung real liquid. So sa part na to, para sa computation, we will consider the area, no, na to to be filled with liquid. Okay? And ito ngayon yung kanyang volume. Ayan. Magiging ganyan siya ngayon. Project natin. So, kumbaga, itong volume na to, ano ang kaakibat na bigat? So, yung kaakibat na bigat niyan, yun yung F2. No? Yun yung F2 magnitude. No? That is acting upward. Okay? So, in that case, so this is filled with liquid, no? Ito, filled with liquid na yan. And this is now our volume for this liquid. We consider the specific weight. At yung formula natin in finding that F2, the vertical component, is simply the specific weight multiplied by the volume of the liquid, no, contained within the volume, no. Okay, sorry, the volume of liquid, no. So so F is equals to, so yung F na ngayon natin, since meron na tayong F1 and F2, okay, so we consider the square root of F1 squared plus F2 squared, no. So ito yung ating F. Next, we consider the angle between F1 and F, theta, where theta can be obtained by taking our tangent F2 over F1. No? F2 over F1. So for case 2, the vertical component of the hydrostatic force on a curved surface is equal to the weight of the volume of imaginary liquid. No? Weight of the volume of imaginary liquid. Ito yung ating imaginary liquid. No? Above the curved surface. Above dito sa curved surface na to. Okay, ito yon. Above sa curved surface na yan. So, we have imaginary liquid. And the weight of that imaginary liquid is equal to the force F2, which is the vertical component of the hydrostatic force. So the component acts through the center of gravity of the mass of the imaginary fluid contained within the volume. So the component F2 acts through the center of gravity dito of the mass of imaginary liquid. Yung mass ng imaginary liquid na yan contained within the volume. No. Ito siya. No? Yan siya. So let's now go to case 3. Fluid is above and below a curved surface. So for case 3, so consider natin itong figure. So meron tayo ditong ating curved surface, no? Ito yung ating curved surface, no? And in this case, may tubig sa taas niya, may tubig din sa ilalim. Oh, sorry, hindi tubig, liquid. In general, liquid, no? Kasi pwedeng tubig yan, pwede rin hindi tubig, basta liquid, no? So in that case, consider natin yon, liquid above and below. Okay? So this is the pre-liquid surface. Okay? Consider natin itong vertical projection of this curved surface. Okay? And this is now the centroid. And this is the area of the vertical projection, yung kanyang right side view, at yung center of pressure, and this is the area. This is the horizontal component of the hydrostatic force, which is F1, acting at the center of pressure. And this is the centroid, and from the centroid up to the free liquid surface, that is HC. We consider the specific weight of the liquid. We can then find F1 magnitude equal to the specific weight of the liquid multiplied by HC multiplied by area. Let's now consider the vertical component of the hydrostatic force. So, consider natin na yung part na to, merong liquid sa loob, imaginary liquid, I mean. There is imaginary liquid sa part na to. Okay? And kasi meron kang force above and force below. Force above and force below. No? So, kumbaga, pag force above, consider natin yung volume na nasa loob nitong curved surface. Okay? So, with that, aside from the volume inside the curved surface that is filled with imaginary liquid, we also consider the liquid above the curved surface. Ito siya. So, ito ngayon yung ating illustration. So, we can neglect itong thickness ng ating curved surface, itong curve path na to, i-neglect natin, gawin na lang natin isa. Okay? So, pag nineglect mo yan, no, so ito yung ating magiging itsura niya. Okay? So, this is filled with liquid. So, kumbaga, ito yung ating sa loob, yung imaginary liquid. So, pati na ito, gawin nating imaginary liquid. Itong thickness niya. Okay? Ginawa na rin natin imaginary liquid. Okay, ganun yung para sa computation, no? And then, aside from that, no? So, meron kasi tayong force above, no? Force acting above, no? So, yung force na to, F2 upward, no? So, ito yung vertical component na upward. So, imagine na meron tayong, we consider yung area ng dalawa. No? Itong area na to, tsaka area na yan. Area ng imaginary liquid, area ng real liquid. So, in that case, ito yung vertical component ng ating hydrostatic force acting upward, na kung saan ang areang may consider ay yung pinagsamang dalawa, yung imaginary and real na liquid. So, dahil pinagsamang area yan, ang center of gravity ay nandito. No? Center of gravity ay nandito ngayon sa part na yan. Kumbaga, kung area yan, saan yung centroid ng area na yan? Nandito. Okay? Ima-minus natin ngayon dahil merong liquid sa taas. Okay? Yung part na to, pabigat siya dito sa curved surface na yan. So kung pabigat siya, may force acting downward. F2 downward, no? Force acting downward. So, syempre, meron din yung center of gravity. Nandito yung kanyang center of gravity. No? So, in that case, ima-minus natin. Kasi, dalawang pwersa yan. Pwersa pataas dahil case 3 yan, fluid is above and below a curved surface. May pataas na ipailalim. Saan mas malakas yung pwersa? Sa taas ba o sa ilalim? So, therefore, ima-minus natin yung pwersa na nasa itaas mula sa ilalim. Kaya F2U minus F2D. No? F2U upward, F2D downward, minus natin yun. Okay, kasi mag-aaway yung dalawa kasi merong above and below. No? So, ito yung sakop ng above, yung dalawang area. No? Actually, volume talaga yan Kung i-project natin, volume talaga yan. Itong volume na to, sakop niya. Yung weight na yan, minus natin yung weight na to. Ayan, minus natin yung weight na yan. So, pag minus natin, ito yung resultang weight. No? Ito yung magiging resultang weight. No? Ganyan siya. So, in that case, yung area na to, minus natin yung area na nasa taas, ay yung matitira yung area na nasa loob ng ating curved surface. At ito ngayon yung resultant ng dalawa, F2U and F2D. Ito yung F2 ngayon natin. This is now the vertical component of the hydrostatic force. No? Acting at the center of gravity of this area, no? So, in the actually, volume talaga yan. Center of gravity of the volume. Kasi meron pa yung part doon, no? So, yon ganyan siya. So, we consider the specific weight of the liquid. So, imaginary liquid yan na nasa loob, no? So, consider natin ito. Okay. Itong volume na yan. Ayan. Yung volume ng liquid. Imaginary liquid yan. So, consider natin yung volume na yan. So, yung volume na yan, multiply natin sa specific weight, makukuha natin yung F2. Kasi minus na natin So, ito yung resultant volume. So, yung bigat ng liquid na to, yun yung F2. So, yung F2 ngayon ay specific weight times yung volume na to. Okay? Yung net volume. Yung resultant volume. Kasi minus na natin yung dalawa. So, ito yung resultant volume or net volume. Okay? So, ito yung ating F2, upward. So, pagkuha ng F, we take the square root of F1 squared plus F2 squared. So, ito yung ating F. Then, yung pagkuha ng angle between F1 and F, arctangent F2 over F1. So, for case 3, the vertical component of the hydrostatic force on a curved surface is equal to the weight of the volume of liquid. No? Real or imaginary. So, is equal to the volume of the liquid, real or imaginary, within the curved surface. So, within the curved surface, sa loob ng curved surface. No? The component acts through the center of gravity of the mass of fluid, real or imaginary. So, yung component na to na F2 acts at the center of gravity of the mass of fluid. Pwedeng real, pwedeng imaginary, pero sa case na to, imaginary. Kasi ganyan yung ating figure, ganyan yung design ng figure. So, sa case na to, imaginary. No? Contained within the volume. So, ito yung ating volume. Meron niyang mass. No? So, at yung bigat niyan ay yung magnitude ng ating F2. Okay? So, that's it. No? So, let's solve a problem. So, the submerged curve AB is 1/4 of a circle of radius 2 meters and is located on the lower corner of a tank as shown. So, this is the lower corner. Okay. The length of the tank perpendicular to the sketch is 4 meters. Okay. Find the magnitude and location of the horizontal and vertical components of the total force acting on AB. So, let's analyze. So, we have here given the submerged curve AB, ito yun, is 1/4 of a circle. 1/4 of a circle, in short. No? 1/4 of a circle or 1/4 of a circle. And is located on the lower corner of a tank as shown. The length of the tank perpendicular to the sketch is 4 meters. So, ito ay 4 meters. No? Ito yung length ng tank na perpendicular dito sa sketch na to. Okay? 4 meters. At yung third dimension, kumbaga. No? So, find the magnitude and location of the horizontal and vertical components of the total force acting on AB. So, kukunin natin yung F1, F2, location of F1, location of F2. Okay? So, let's analyze. So, let's start with F1. Yung F1, ito yung center of pressure. Ito yung ating vertical projection. Ito yung formula ng F1. So, specific weight. So, ito yung centroid ng ating plane area. Ito. Kasi sabi dito, perpendicular sa sketch. 4 meters daw. Ito. So, kung 4 meters yan, sabihin yan, kung 2 meters ito, no? 2/4 siya nun. Yung third dimension, 4 meters na yun. No? 4 meters to. No? Ito yung para sa third dimension, 4 meters. So, yung right side view. Ito yung right side view niya, no? 2/4, no? Or 4/2. 4 meters dito, 2 meters doon. Considering the third dimension. So, this is HC. No? So, and then, so yung HC na yan, yun yung distance between the free liquid surface and the centroid. So, this is the area. So, makukuha natin F1. So, we consider the temperature of water here to be at 4 degrees Celsius. So, the specific weight now of water at 4 degrees Celsius is considered multiplied by 4 plus 0. So, yung HC, bakit siya naging 4 plus 0.5A? Actually, ito yung A. Ito yung B. Diba? Naturo ko na yan dati. So, kung yan ay A, ito yung centroid, ito yung part na to, dahil yan ay rectangle, A over 2 yan. No? A over 2. That is 0.5A kasi A over 2. 0.5A. Kaya, yung 4 na yan, idagdag mo pa to, yung para dito, 4 plus itong part na to, no? Ito ay 4, di ba? 4 meters plus itong 0.5A. Kaya ganyan siya. Okay? And then area of the rectangle BA, no? So the specific weight of water at 4 degrees Celsius is 9.81 kilonewtons per cubic meter. So then 4 plus 0.5, A is 2, no? So pareho namang meter yan, 4 meters, 0.5 times 2 meters, kaya pinactor out ko na yung unit. Then B is 4 meters, A is 2 meters. We get an answer of 392.4 kilonewtons. Okay? So that is the horizontal component of the force, of the hydrostatic force. Next, we consider now the location of F1. Consider naman natin yung location of F1. So ito yung ating eccentricity. Ito. And then, ang eccentricity natin ay IXC over HCA. Tinuro ko na yun dati, right? So, ito yung moment of inertia about the XC axis, which is equals to B, A cube over 12, all over HC is 4 plus 0.5A. Area is PA. So, ito yung magiging outcome, 4 2 cube over 12, M to the 4th, all over 4 plus 0.5 times 2 meter divided by 4 meters times 2 meters. And we will get 0.06667 meters. Okay? So, yun siya. So, ito yung HCP natin, the distance between the water surface up to the horizontal component of the hydrostatic force. So, HCP. So, yung HCP na yan ay HC plus E. Pag pinag-add natin yung HC and E, we get HCP. This was discussed before, right? So, just review the previous lesson. No? So, next. So, HC is 4 plus 0.5A plus E. And we get A is 2 meters, E is 0.06667 meter. We get 5.067 meters. So, we can now state the location of F1. F1 is located 5.067 meters below the water surface. Ganun lang kasimple. F1 is located 5.067 meters below the water surface. O kaya, pwede mo sabihin na F1 is acting 5.067 meters below the water surface. Okay? Now, let us consider F2 now, F2. Para sa F2, consider natin itong curve AB na kung saan sa taas niya may liquid. So, ito yung ating F2, the vertical component. So, take note case 1 to. Case 1 ng hydrostatic force on a curved surface. So, F2, so acting downward, center of gravity, ito. Okay? Setting F2 natin, center of gravity. So, we consider the specific weight. Setting volume na ma-form. No? Okay? So, yan yung considering the third dimension. So, ito yung volume na yan. Okay? And F2 is specific weight times the volume. So, the weight of the liquid here is simply the vertical component of the hydrostatic force. So, take note. This is the length perpendicular to the sketch. Therefore, ito yung third dimension length. 4 meter. No? So, 4 meters yan. Okay? So, kumbaga, merong tubig dyan na 4 meters yung length niya dito. Sapat na to. Okay? Next, we have, so we consider the base. Itong base ng ating area, no? Area of the base, no? Ito yung consider natin base, ang ating base area. Tapos yung length. Yung length na yan. So may kinalaman kasi yan sa pagkuha ng volume. Yung ano? So paano natin kukuhanin yan? So ang volume niyan ay simply yung area ng base multiply mo ng length dun sa third dimension na 4 meter. Yung haba, no? So therefore, the volume of the liquid is simply BL. No? At take note, dahil yan ay BL, at irregular shape siya, hindi siya ordinary shape. Hindi siya rectangle, hindi siya circle. Pinaghalo, composite figure siya. Therefore, pwede nating hatiin. Hatiin natin sa dalawa na common figure. Isang rectangle, isang quarter circle. So, sabihin natin, B1, ito yung base ng ating area. Sabihin natin B1 is the area of the rectangle. B2 is the area of the quarter circle. So, take note yung B na yan, kinonsider natin as area of the base. No, area of the base. Kinonsider natin siyang area of the base. So, ito yung ating base area, rectangle. Another base area para sa ating quarter circle. So, therefore, yung base area na yan ay yung pinagsamang dalawa, B1 and B2. No? So, in that case, so naulit lang, kunin natin yung F2. So, that is 9.81 kilonewton per cubic meter multiplied by B1 is the area of B1. Yung area ng B1 ay area ng ating base 1 ay 2 times 4. Right? Paano siya naging 2 times 4? Diba, ano to? Ito ay 4 meters. So, ito ay 4 meters. Yung part na to. Okay? Tapos, ito ay itong haba na to ay ano? Yung haba na yan. This part, ito yan, di ba? 2 meters. Itong part na to, 2 meters. Kaya 2 meters yan. So, 2 times 4, di ba? Tapos, ito ay 2 meters, di ba? Radius. Radius ng quarter circle, no? So, we have 2 meters. So, kung quarter circle yan, so alam natin yung circle, ang area niyan ay pi r squared. Kung 1/4 lang ng circle, so tingin mo sa apat, yan. So, yung part na to, 1/4 lang ng buong area. 1/4 pi r squared. Itong area na to. Ayan. Diba? So, 1/4 ng pi, radius is 2, diba? O, 2 squared, pi r squared. Then, meter squared. Yan. 2 times 4, inano ko na yung unit. Pinactor out ko na. Then, the length is 4 meters. Ito. That's it, no? So, ang sagot ay 437.2 kilonewton. Okay? 437.2 kilonewton. So, yun yung ating magnitude ng ating force. No? Which is also the weight of the liquid above this curved surface. So, 437.2 kilonewton. Next, consider natin itong, so, location naman ang hanapin natin for F2. So, consider natin ito, dahil ito yung ating concern natin ngayon, Z bar. Yung distance mula A hanggang center of gravity. No, yung distance na to, horizontal distance. Sabihin natin Z bar 'yan. So para malocate natin yung location, hanapin natin yung Z bar. So recall location of a centroid coordinate. Paano ba natin nilolocate yung centroid coordinate? Ito ay topic sa calculus actually, no? Centroid, no? So, ito yung centroid ng ating rectangular area. Yan ang centroid. Ito yung centroid ng ating quarter circle. Nandito. Ito yung centroid ng ating pinagsamang rectangle and quarter circle. Nandito, yung centroid niya. Ngayon, ito yung reference natin. A yung reference natin, no? Reference natin yan. So, itong part na to ay katulad nito, Z bar, no? Z bar. Yan, no? Next. So, ito ay, kung Z bar yon, ito naman ay, sabihin natin Z1. Yung distance na to ay Z1. Yung distance na to ay Z2. No? Setting reference natin. So, ayan. So, para anong relationship ng B and Z? So, yung sabihin niyan, yung area ng base, pag minultiply ko sa Z bar, makukuha yung kaparehong area kapag minultiply ko yung B1 sa Z1 at inad ko dun sa B2 and Z2. No? Tandaan nyo yan, no? So, para sa paglocate ng centroid coordinates, so, ito ay topic sa calculus, actually, na hindi naman talaga part ng lesson natin. So, in this case, B, yung kabuang area, multiply mo sa kanyang centroid, ay katumbas ng pinagsamang dalawa na to. Yung area ng ating rectangle, i-multiply mo sa kanyang centroid coordinate, Z1, plus area ng ating pangalawang figure, which is B2, multiply mo sa kanyang centroid coordinate, Z2. So, makukuha natin yung katumbas ng pinag-multiply na B and Z bar. So, in that case, ang concern natin is Z bar, no? The component or the coordinate of the centroid of this area, no? Area of B. So, in this case, B1 is the area of the rectangle, 2 times 4, diba? Area of the rectangle, diba 2 ito, tapos ito ay 4. Area of the rectangle, 2 times 4. Tapos, Z1 Recall natin yung sa centroid. Paano yan? Sa centroid ng rectangle, kung ito ay Z1, kung ito ay 2, sabihin niyan kalahati ng 2, yun yung Z1, right? Para sa kanyang centroid coordinate. So, kalahati ng 2. Okay? So, yun ang ating Z1, kalahati ng 2. And then, so, unit meter, so cubic meter, no? Next, we have V2. So, this is 1/4 of pi r squared. Area ng ating quarter circle. So, 1/4 pi. Then, we have the radius of the circle, which is 2 meter. No? So, imagine meron tayong full circle. So, ito yung ating 2 meter radius. Okay? So, squared natin yon, multiply ng C2. That is yung centroid ng quarter circle. Na-discuss ko na yan before. No? Na-introduce ko na para sa centroid ng isang quarter circle. Okay? So, in this case, if this is the radius, this is the radius. Ito yung centroid. So, itong distansya na to, ay 4r over 3 pi. Okay? Recall nyo panoorin nyo ulit yung video or tignan nyo yung PDF file na in-upload ko dati. Nandun yung itong formula na to. No? Centroid coordinate ng isang quarter circle. So, nandito siya, 4r over 3 pi. Kaya, 4 radius is 2 meters over 3 pi. No? And then, cubic meter. So, meter squared times meter, so cubic meter. No? Then, the area of the base. So, 2 times 4 para sa rectangle. 1/4 pi r squared, 1/4 pi 2 squared para sa quarter circle. Then, ang unit ay square meter. No? So, what will be our answer now? So, our answer is 0.9574 meter. No? Alright? So, I hope you get it. No? So, in that case, we can now state the location of the vertical component of the hydrostatic force. So, F2 is located 0.9574 meter to the right of A. No? To the right of A. Or, F2 is acting 0.9574 meter to the right of A. No? So, there's an alternative solution to the problem. So, we consider the full circle formed when curve AB is extended. No? Pag yung curve AB ay na-extend, so full circle na siya. No? The resultant hydrostatic force acting at the curve AB, no? Ito yung ating curve AB. The resultant hydrostatic force acting at the curve AB passes through the center of the full circle. So, ito yung center ng full circle. No? So, nandito yung center niya. At yung resultant, which is F, yung hydrostatic force, ay tumadaan sa center ng circle na to. Tumadaan siya. No? Dumadaan siya sa center ng circle na yan. Okay? So, kung ganon, ito yung ating F. Okay? The resultant hydrostatic force acting at the curve AB passes through the center of the full circle. So, kung dumadaan siya sa center ng full circle, so yung center na yan, sabihin natin, point O. Center ng circle, point O. So, sabihin yan, pag nag-moment tayo sa O, dahil dumadaan yung resultant hydrostatic force dito. Pag nag-moment tayo dyan, ibig sabihin niyan, zero yung ating moment. Dahil, pag yung force dumadaan sa point na kung saan magmo-moment tayo, zero ang sagot. No? Zero yung sagot. No? So, in that case, thus taking moment at the center of the full circle will result to zero. Okay? So, yan ay topic actually sa engineering mechanics which is not part of our lesson talaga. No? So, just review your engineering mechanics subject. No? The static of rigid bodies. So, in this case, we take the moment at O. No? We take the moment at O and equate it to zero. No? Ito yung ating point O. No? Kasi yung ating hydrostatic force dumadaan dyan. Dumadaan dyan. So, pag dumaan dyan, pag nag-moment tayo dyan, zero ang sagot. No? So, we take the moment that O is equal to zero. No? So, in that case, we take the clockwise direction as positive para sa pag-take ng moment. So, in that case, this is F1. Okay. Acting at the center of pressure. Okay, and this is the eccentricity, the centroid. Okay. So, in this case, yung pagkuha natin ng F, so summation moment at O, no? So, paano nakuha yan? Actually, ito yung ating F2 kasi, di ba? No? So, sabihin niyan, pag nag-moment tayo dyan, F2 times Z, positive, no? F2 times Z, ito, Z bar. Okay? So, gaganyan siya. So, counterclockwise direction, so positive. Minus, ito naman, F1 times itong distance na to. Okay? F1 times itong distance na to ay E plus A over 2. Ito ay A over 2, right? This is A over 2. A over 2 plus A. Okay? So, minus natin yon, equal to 0. No? Then Z bar is equals to, so transpose natin sa right, we have F1 multiplied by A over 2 plus E all over F2. No? So, nag-take tayo ng moment at O. So, taking moment at O, so, nakuha natin ito. Okay? Kasi, yan yung mga components ng ating hydrostatic force. No? So, therefore, ang summation niya ay 0 dahil ang resultant ay nagpa-pass through sa center, sa point O. No? Point O ng ating quarter circle. Alright, then we have, so ito yung mga nakuha nating sagot in the previous slides, no? So we have now F1, 392.4 kilonewton over F2, 437.2 kilonewtons, multiplied by A is 2 meters, no? 2 meters over 2, so sabihin niyan, this is 1 meter, plus E, 0.0667 meter, 6667 meter, no? So we will get an answer of 0.9574 meter, which is the same, no? Same as in the previous solution, no? So therefore, we can finalize our answer. So The vertical component of the hydrostatic force is located 0.957 per meter to the right of A. No? So that's our final answer. No? So that ends my discussion. No? I hope you get it. Good day, everyone.